Good afternoon, everyone. Good afternoon, honored Japanese guests, and welcome to these talks organized by Politecnico di Torino within the Italian pavilion at Expo Osaka 2025. My name is Gian Mario Pellegrino. I am professor of electrical engineering, and today I am welcoming you on behalf of our rector as a delegate for technology transfer and relationships with the industry and companies. So it's my pleasure to introduce this third afternoon dedicated to Japan and organized by Politecnico di Torino. Among the Italian pavilion, we are the only university selected for showcasing our links to Japan and capabilities, together with the only exception of the University of Venice. So it's just two universities of more than 100 universities in Italy. So the topic of today's speech will be Wings of Innovation, so the future of aviation. This will be the first segment of today's interventions, and then we will have a second moment dedicated to the future of space economy. Aerospace is the key area that we selected for this project in the Expo Osaka. The project is called Heron, or in Japanese, the word is sagi, and resembles, of course, air mobility, and somehow space. And this was the design of this room that you see. We have a logo in a stamp here. So I invite you, before leaving, to take a memory. We have a postcard. You can use the stamp on it. It's Polito and Japan together. And before we leave the floor to the speakers, let me speak about the Polito Japan Hub, that red logo that you see in the right corner. That is our initiative started in 2023, initially in Kyoto, and last Monday we inaugurated the new Polito Japan Hub office in Tokyo. We moved to Tokyo, and we are investing more and more in our physical presence in Japan, so to strengthen the relationship between Italy and Japan. We have also the director of the Polito Japan Hub, Professor Quaglia. You can meet him. Here is our director. You can meet him later on. We will have refreshments around 6 p.m. in this same room. And finally, let me introduce our speakers today. We have a first moment that is dedicated to advanced air mobility. There are three colleagues of the aerospace, mechanical engineering and aerospace engineering department that will be presenting this part. They are also, the activities they will showcase are in collaboration with the National Center for Sustainable Mobility, which is a center gathering a number of Italian universities and industries and companies. And then we will have switch to the second half of the technical presentation dedicated to the space economy, and we will have a single speaker in this case. So for the first part, I will invite Professor Giorgio Guglieri, Professor Gioacchino Cafiero, and Professor Elisa Rosso to speak. Sorry. Last mile, the last step is the more critical. Elisa Capello, sorry. Sorry. Who is Elisa Rosso? I don't know. Sorry for that. I was pretty much perfect, but I missed the last step. Okay, so let me invite Professor Giorgio Guglieri to the podium for the first speech.
Okay, thanks a lot for the introduction. Very shortly, I will try to outline what is happening in terms of applied research driven by funding from government funds deriving from an action that was concentrated in the last 3 years at a national level that is designed by a newly founded Center for Sustainable Mobility that is called the MOST. That is the name of this specific institution. I'm talking here as I am the leader of one of the vertical spokes acting within the National Center, so that's the reason. By the way, I'm also the head of the Department of Mechanical and Aerospace Engineering in Politecnico. Okay, MOST is, in Italian, is Centro Nazionale per la Mobilità Sostenibile. It's a public-private foundation founded in 2022, and the original funding was something like 300 million euros, provided by the National Recovery and Resilience Plan. That is a European plan for restarting Europe after the COVID crash, mainly. The strategic priorities of these activities are human capital, applied research, innovation addressed mainly to startups and small, medium enterprises, and finally, advanced technologies for the public sector and the private industry. Currently, the organization of MOST includes 49 partners. Specifically, there are 24 universities, Italian universities, and 24 companies, plus the National Research Council that is also part of the game. When you see the companies, you recognize many important brands of our nation, from Ferrari through Hitachi in Italy, and many others like Thales Alenia Space, that is also operating in the space sector, Leonardo, that is a stakeholder for aviation, and Avio Group, that is also another important stakeholder of the aviation sector. We gave the numbers, that is 380 million euros of investment in 3 years, and an overall involvement of something like 3,000 experts from the industry and from the universities and the research centers in Italy. As a byproduct, we extended the involvement of the companies through the affiliates that were later introduced as partners of the project. 5 vertical transportation lines: air mobility, road vehicles, waterways, that is naval transport, rail transport, and light vehicles and active mobility. These 5 ways of moving around are intersected by a line of applied technologies that are enabling the development of the five vertical transport segments. The first vertical transportation system, air mobility, is Spoke 1, and I'm leading the Spoke 1 at a national level, so I will try to give a very short outline of the content of the activities performed by this spoke. The partners are academic partners. Okay, Politecnico di Torino is leading, but we also have Politecnico di Milano, University of Bologna, University of Naples, Federico II, Roma, University of Rome, Sapienza, and University of Bergamo. Companies, Poste Italiane, who is the major stakeholder for postal services in Italy, but means also flying aircraft. Leonardo, Thales Alenia Space, and Teoresi and Accenture, which are mainly consulting, industrial consulting company. Well, we have many purposes in this project, and the future of green aviation is one of the timely targets that we have. but also the solution for logistic alternatives based on airborne system, how to interconnect, as I make an example, autonomous flying vehicles with conventional road vehicles or rail systems. These multimodal transportation systems are the future of transport. Providing guidelines for design of innovative aircraft is also another purpose. The fact that we can pilot aircraft with a single pilot or without a pilot is also an issue that is still open and needs a lot of work. The evaluation of market opportunities for new technologies. This is also relevant because without a sustainability in terms of money, you don't go anywhere. So you need to demonstrate that whatever is the technical solution, the technological solution you're providing, you need some type of economic foundation behind. Okay, these are the work packages. I will skip this. And when we deal with advanced air mobility, we mean something that is a very, let me say, unshaped system of aviation that is still being defined. Is in a very simple way of explaining what is not conventional in aviation. That means it's not a conventional aircraft, it's not a conventional helicopter. This segment of aviation is nowadays still very small, but is increasing very rapidly. Drones is part of this, but it's not only the segment that we are considering. We also include hybrid propulsion as a solution for regional transport. We are considering also capacity of carrying people and goods on medium and short distance with autonomous lifting systems. We need enabling technologies. These enabling technologies are very wide. X reality, whatever is immersive or providing an immersive capacity. Hybrid and full electric propulsion, the dream of designing finally fully electric aircraft is still ongoing. It's something that we will see, and the target is 2050, so it sounds to be far, but it's very close. The fact that you need the lightweight and advanced materials, functionally graded materials, or materials that are part of the design of the vehicle, and the capacity to realize twinning system, digital twinning system of the entire vehicle. This is something that has to come, definitely. Within the project, we aimed to some demonstration activities that I try to summarize here, and I will show very few of them, just to demonstrate that we did a job on this. And I go directly to one of the projects that we performed, that is the project called Isole Minori, Minor Islands. That was an experimentation for a postal service based on light drones. The weight of the drone is something less than 100 kilograms, but it will be scaled up currently to 300 kilogram takeoff. That means that now we are transporting 30 kilograms of mail. In the future, it will be transporting something more than 100 kilograms. And the experiment were performed in Naples, connecting the main coast with an island that is a distance of more than 10 miles, more or less. That's 20 kilometers, more or less. These experiments were performed for 6 months on a daily basis with multiple flights in multiple weather conditions, in multiple operative conditions, and it was a full success, definitely. It was impressive, the result. The idea is interconnecting the aerial transport system with the vans that provide the feeding of the vehicle, and once again, the vans that are spreading the mail in the island that may not be fully connected when the bad weather is coming. Okay. Another demonstration activity, we realized experimental cages for drones that are indoor facilities, and on the right you see there is a generator of aerodynamic obstacles. What is an aerodynamic obstacle is something like a gust, but it's more than that, because it's time and frequency in domain characterized, so it's something that is very similar to the aerodynamics that you find within the buildings. Flying between the buildings is a very bad idea, because normally we don't fly between the buildings, but because the aerodynamics is horrible. And so simulating the aerodynamics within the buildings in a very critical interaction with the external aerodynamics of the environment is extremely timely. I will skip through the other demonstration activities that we perform that are very wide, from X-reality to the design of active drag control on the surface of the wings using plasma actuators. That is something very, very innovative. And the analysis of economics in terms of sustainability of a mixed transportation system. There is a lot of talking about the use of drones for the transport of goods and passengers, but is this system, even if we don't have it, potentially we will have it in the future, is this sustainable compared to the conventional transportation system? Mainly the answer is no. Today is no, because it's too complex, too heavy, too expensive. It's definitely an asymptotic target that we give to our technology, but it's still not mature for the purpose. Okay, digital twinning is another point. The capacity to design digital twins of components is being tested and experimented within labs and also in collaboration with the companies. Two major side effects. We created an Italian observatory for sustainable civil aviation that is an association of stakeholders that is trying to provide at a national level an outlook of civil aviation. Mainly there are three pillars, that is advanced and urban air mobility, digital technologies, and advanced logistics for aviation. That is also part of the purpose. Second side effect, we created, always with the funding of governative funds, with the support of governative funds, two innovation infrastructures that are is for aerospace and ISM for Italy. These two infrastructures have the purpose to increase the technology readiness level below 5, that is typical of the research, the applied research that we perform within MOST, to a level that is closer to the product. These two innovation infrastructures are located in Torino, and both of them are involving the major companies of the sector, the aviation sector, just for the purpose of developing together the prodromes of commercial solutions that are being realized by the industrial partners. Okay, I try to be very quick just to leave the floor to the colleagues that are coming. Gioacchino, the floor is yours.
Thank you very much. First of all, thanks a lot for this opportunity. I'm Gioacchino Gafiero. I'm a colleague of Giorgio and Elisa. I'm an associate professor of aerodynamics in the Department of Mechanical and Aerospace Engineering, and I'm one of the team members of the Spoke 1 Air Mobility that worked on the projects that Giorgio mentioned before. So what I will do in the next few minutes is to try and give you an idea of what we've done in some of the activities that were already pointed out by Professor Guglieri before. And, no, wrong way. Sorry. And specifically, what we did was, as you've seen from the previous presentation, we did a lot of things. We worked on sustainable aviation, we worked on economics, but one of the pillars of our activities was really advanced air mobility. So when we started thinking about this project, we really wanted to make an impact, and to do this, we understood that following also the results that were pointed out by EASA, the European Agency for Safety and Airworthiness, we really need to start from the people. So if we want to talk about advanced air mobility, we really need to take into account the fact that these vehicles will somehow fly over the heads of people in the cities, and as Professor Guglieri mentioned before, flying in urban canyons and stuff like that, it's not really a good idea in general. So we need to make sure that this is safe. And the two most pressing matters for people are noise and indeed safety. So the kind of things that we try to address are the annoyance, public annoyance, so more specifically related to noise, the analysis of the performance, and more specifically how to improve the performance of these vehicles, and the use of collaborative systems to enhance somehow the safety and reduce the risks of the operations. Sorry. Okay, so to do this, as you, well, the activities that I mentioned are quite, let's say, different. They don't belong to a single pillar, a single activity, but it's really a matter of joining different disciplines, right? So it's really important to have an holistic approach to this kind of problem. And this is what we try to do. So we try to start from fundamental science and bridge the gap with actual, real, let's say, implementations of these technologies. And to do this, we tried to go through the different steps, right? So we started from the enabling technologies for advanced air mobility. You've seen this GIF before in Professor Guglieri's presentation. This is an example of the application of active flow control to improve the performance of fixed wing or tilting wings aircraft. And so this is really aimed at improving the performance pillar that I mentioned before, or the introduction of artificial intelligence to improve the capability to respond to such challenging environments, such as the ones that are characteristic of urban environments. Here you see an example where you have a flap that is kind of counteracting a gust generated by the wind wall that was mentioned before, or the study of innovative UAM configuration. So in general, when you move from a large-scale aircraft to a small-scale drone, you cannot think that it's going to be exactly the same craft. Something must change. And so we really need to think about solutions here. For instance, you have distributed propulsion that allows you to achieve significantly lower level of noise. So you see that here, through these three enabling technologies, we somehow tackled the three problems that we highlighted before. So performance, risk mitigation, and noise reduction. A second step was to develop some new facilities. So the ones that we had before and that were available were not sufficient. I'm not saying that were not useful, but we needed more. And to do this, Professor Guglieri mentioned this before, more specifically the flying arena, that is a multidisciplinary arena that we developed at Politecnico di Torino, where you have the wind shaper, the wind wall that generates spatial and temporal varying inflow conditions, but this is also equipped with a 12 camera system to track the drone while it's flying, or any object, really, for what it matters. And the nice thing is that with this project that we carried out along with Poste Italiane, a stakeholder in the delivery systems and University of Naples, we managed to reproduce the effect on drones in different inflow conditions that are representative of coastal areas, urban areas, and mountains, because it's really a matter of having different inflow conditions that can change the performance of these drones. Of course, we also needed to step up in terms of the capabilities to measure something, and so advanced flow diagnostic. We developed some new techniques, and some of these are actually also part of patents that we submitted. And this will be spoken about more in the next talk, but the use of a 12-camera system to track drones, so multi-drone systems in realistic environments. Last but not least, so we have to bridge the gap from fundamental science to applied science, and to do this, the National Center for Sustainable Mobility also supported the activities through some specific actions that also involved stakeholders of the territory, such as small and medium enterprises, but also startups and spin-offs of Politecnico. Some examples are reported here. This is a very nice application where you have a drone that is being used for the dispersion of, well, basically for precision agriculture. Sorry, in the hill area near in Piedmont. Or another activity that is related with innovative solutions used for urban air mobility vehicles. Here we had a seed core funding from the National National Center for Sustainable Mobility to support the development of this innovative drone of a startup of Politecnico. So all of this is really a platform that allowed us to think to the future, right? So we started from this kind of ingredients, but now after 3 years of activities, we don't want to stop there. So what's next? What are we going to do next? And one of these activities is related to IS for aerospace, which is partly is also supported by the recovery fund that was mentioned before, and is a platform where there is the collaboration between public and private companies. In particular, you see 3 major stakeholders in the field of aerospace: Avio Aero for activities related with high-performance computing and GPU-accelerated high-performance computing, AI with Leonardo, and Thales Aerospace for material and manufacturing. Another important activity that is being developed now in Torino is IDEAS. IDEAS is a new center developed at Politecnico that will allow us to develop new laboratories along 3 main pillars. 2 of them are related with space, upstream and downstream segments, respectively, and the last one is related to aviation. And in particular, trying to tackle 2 main aspects that are the advanced air mobility and the sustainable aviation. I just want to conclude by giving you an idea of what we want to do within these IDEAS lab related to AAM. And so we really want to have let's say, the capability to build some digital twins of drones that are flying within realistic environments in order to accelerate the simulation of these conditions. Because nowadays, this is really expensive, it's data hungry, and it requires a lot of resources. So we really need something to validate these models and to obtain something for the near future and for the design of new drones. With this, I conclude and I leave the floor to my colleague, Professor Capello.
So good afternoon, everyone. So we started the presentation just with the introduction of the project. We moved to the multidisciplinarity of the project, focusing on the advanced air mobility. And now the objective of the last presentation is just focusing on a specific application, and in particular, of course, a collaboration with Japan, and in particular with the University of Osaka. So the keywords of this last part of presentation will be multimodular or multi-agent system in unstructured environments. So which is the idea? We are, as told before, in urban environments, and so we have different buildings, obstacles, and we need to handle complex tasks. And the idea is to increase the overall mission performance, not only using aerial system that we showed before, but also some ground vehicles. So focusing, as I told, this presentation is just focused on some technical aspects of the project, so which are the main steps for handling this kind of task. So we first start with the algorithm development. So the picture here, you cannot see the pointer, but the upper, start from the up, there is the drones that is actually in a simulation environment. So first we start with simulation environments with the software in the loop, and after we move to the hardware in the loop approach. As told, we have nice facilities, that is an indoor facilities in which we are testing all of our algorithms, and we have a beacon motion capture system for the position and a wind shaper, as Gioacchino and Giorgio well explained. But we also have an outdoor actually cage in which we test again what we are doing indoor, handling different systems. And in particular, we can add in the outdoor cage also some specific obstacles just to manage the presence of buildings in the urban environment. So which is the context? The context is a multi-robot collaboration. So we have ground robots and aerial system. All the systems should be different. As we usually say from the theoretical point of view, they are heterogeneous agents. They are working in a complex task and a dynamic environment. Which is the meaning of the dynamic environments? As I told, we are in an unstructured environment, or dynamic, as I said. So it's an environment that lacks of a defined structure or organization. So which is actually the scenario? We have a ground robots with some sensors, and we have an aerial system with different sensors. And we have to understand how these agents or systems are cooperating each other in an environment that is unusual, let me say, like the one in the picture, with some buildings and obstacles. Of course, the environment is unknown, so we don't know the environment a priori. So the research question is how to fly information without a centralized coordination, and this is a joint work with the University of Osaka. So we start from studying the nature, so the flocking of birds. We put some mathematics, and after we moved to a distributed formation flying. So which is the purpose? We have 3 domes, for example, in this picture, that are in a fixed position, and they have some velocity, and we have to create a formation. So at the end, all the velocity are matching, and the formation is created with a fixed distance between the agents. We start, as I said, with the first step, that is preliminary simulation, really simple. So just made some simulation, so we are not considering any uncertainties. We move to a detailed environment, and as the picture shows, we have not only one agent, but we should have more than one agent. And finally, we attach our system. We can see exactly this drone over there. That is the one that we are using in the lab, attaching this to the laptop and testing if we are doing a great job. Of course, we cannot skip experimental tests, so we can use this arena actually for testing our algorithm, considering different onboard brains that can be useful for manage all the software, and we cannot miss, of course, to have sensors. We can do this for a separate agent that is actually an aerial system, and we can move to the ground vehicle, and the steps are of course the same. So we have a software in the loop, and we have a simulation. We attached again our ground robots to the laptop, and we are checking all the code. And after we are doing some experiments. Actually, the scope of this application is very specific because, as a reminder, we are in a urban environment and we have obstacles. And so we cannot know a priori where the buildings are. And so here is an example of the ground robots that is looking with a sensor, so what is happening around and where the obstacles are. Here we have a fly, so the second video. Okay, from a different point of view. So I told you that we can, that we can study this in a separate way, but finally we can manage to have different sensors and a different system. So the aerial system have some specific sensor, and the ground have different sensors. So they are communicating each other, and the scope here is to have the aerial system that will track the ground robots, and after they are moving together and following a specific path. The video is quite long, and we put also some disturbances thanks to the wind shaper that Giacchino showed before. Which are the work in progress? As told before, we are trying also to combine everything with an extended reality. And so here in the video we can see the drone that is flying in the outdoor cage, and in the right is what the sensor is imagined to see. So we are in a urban environment because the cage is the outdoor facilities. He has to land somewhere, and we can just have different scenarios just thanks to the extended reality. So the ground and the aerial system are managed by a ground control station. So we have some sensors, and some of these sensors are just virtual. The second work in progress is developing of a hybrid navigation framework in specific for ground robots, and is a collaboration that just started with the NARA Institute of Science and Technology. And so here, the idea, here I put just the name of the algorithm, but just imagine that the Scopus is the same as before. So we have an attraction that is the final point and some obstacles that are the buildings. And we can generalize the environments, and the environments is not known a priori. And we can also share information between the agents, and we are using some deep learning or AI algorithm just to consider every kind of scenario or several scenarios. So this is a joint works, and I would like to thank, of course, the Italian collaboration and the Japanese colleague that are here in the audience. So I start from the left because it's a long history. So I have a connection with Professor Yasumasa Fujisaki of the University of Osaka. More than 10 years ago, we started this collaboration. I have also collaboration with Professor Satoshi Sato. Sorry, I start from the last name. Satoshi Sato in the same university, and now I'm started a collaboration with Professor Takamitsu Matsubara of the Nara Institute of Science and Technology. Of course, I have two key persons from the Italian side that are the assistant professor Fausto Lizio and my PhD student Petre Riccioppo. This presentation was made by me and the other colleagues, so thank you for the attention. Grazie, arigatou gozaimasu, and it's a pleasure to be here.
Okay, thanks for this very engaging presentation. Now we move to the new space economy. So I invite Professor Giuseppe Scellato to the podium. He will be speaking on behalf of Politecnico di Torino, of the activities of Politecnico di Torino within this innovation ecosystem. Again, it is a nationally funded enterprise where companies and universities are collaborating. Please, Giuseppe.
Thanks. I need to change my presentation here. That's not this one. Ok, not working this one. Non so se funziona questo.
Sì, quello.
All right, good afternoon, and thanks for this opportunity of being here and presenting a number of activities that we have put in place at Politecnico di Torino concerning the space, or better, how to say, the new space economy. If you had the chance of visiting this pavilion about Italy, you have seen how central is the aerospace industry and how important it is for the future trajectory of development. So in my presentation, I will take a quick tour starting from key global trends about industry growth, talking about aerospace, and then moving down to the cluster level, and finally trying to introduce you the key players that are active in our region, in Piedmont, and the specific activities of Politecnico di Torino, and finally the project that I've been leading for the past 3 years. It's called NODES on aerospace. So we start with the key global trends. You see, we are really undergoing what is called a structural change in this industry, connected to a steady growth of the sector in the past 10 years and then an expected continuing growth for at least for the next 10 years. And there are 4 key drivers behind this economic growth. On the one side, clearly, we work on technology, and there has been an important technological evolution that has led to, I'm just picking a couple of points, lower cost of accessing space, a reduction you can see here in the space assets, and a number of new technologies that can be incorporated in payloads. But it's not just a story about a technological evolution. The value chains in this industry are changing. An increasing role of space data for engendering also downstream application. And then there is a geopolitics of space, but that is very important, as you can easily imagine, with a push by different countries to achieve technological independence in the field, and inevitably also stronger links than in the past with the defense application and security. And finally, there is a growing role about new ventures, startups emerging in the field, both in the upstream and in the downstream segment. And it's quite unusual that 4 joint changes takes place at the same time. If we transform these into market value, how much is the size of the space economy nowadays? Here we have the most recent estimates divided by the upstream component and the downstream component. So overall, now we are a little bit less than €500 billion on a global scale. This number is expected to double, so reaching €1 trillion in the next 5 to 10 years. But what's the weight? I'm not talking about Italy. What's the weight of Europe now? And you see, as a continent, we account for only 6% in the upstream market. This is a little bit more, 20% if we look at the downstream sector. And so what are the institutional budgets? Here we are in an international environment. It's very important to understand that in the 2024, in terms of overall institutional budget on a global scale, there is still a very important leading role of the United States. Europe accounts for 10%. Japan, you see, 5% in levels. And if we go to space budget as a percentage of gross domestic product, you see in this case, Italy is in line, I would say, with the average European countries. Japan is spending relatively more on space applications. But there is also a subset, 2 very relevant technologies I would like to illustrate to you. One is EO, which stands for Earth Observation Application, and then space navigation. If we just look, so now we are not looking at the upstream components, but at this type of application for Earth observation and GNSS. In this case, the composition in terms of revenues of the industries operating this field is quite different. Still predominance of the United States, but also Europe has a more important role, as well as Japan in the case of navigation services with a very important cluster operating in this country. We have been mentioning startups as a potential driver of the growth of the industry. Here you see the global investment made by venture capital firms into startups, divided by country, not of the fund, but these are the countries of the target companies. There has been an increase. I would say this increase is now lowering down a little bit. There is a process of consolidation in the field, and an important role again of the United States, followed by China in more recent years. Until now, we have been talking about countries, that unit of analysis, but in the specific case of aerospace, I would say, and space in particular, the industrial activity, the research activity turns out to be very much clustered by a geographical point of view. So, and this is because we need a pool of highly specialized knowledge and human capital that is not evenly distributed within a country. So for this reason, we made we try to investigate more, and with this issue, and with my research group, we make an effort to develop a unique database. It's called the European Space Sector Database. It's a database about cluster regions that have been producing scientific capabilities, human capital, presence of industry leaders across Europe. Now I'm trying to use this database to tell you something about the Turing-specific ecosystem. In the database, just to have an idea, we have collected more than 200,000 scientific articles in space-related journals. We collected a large number of patents worldwide. We measure the presence of large companies or SMEs active in space, all the space startups active in Europe. We even counted the number of students in aerospace engineering or related fields, and we also look at specific centers for incubation of startups. So imagine putting together all this data, and then we benchmarked Piedmont, Turin, basically, with all the other European clusters, about 60 other regions, and trying to see whether on this dimension, how we benchmark with these other clusters. Here you see the number of type of indicators in which our region is located among the top 20% of the region in two periods of time. So this data reveals a number of key points. There is a prevailing focus in terms of innovation in our region on the upstream technologies and satellite relative to downstream. Consolidated scientific and human capital base. This is based on numbers, all those publications and patents we went through, and a growing entrepreneurial ecosystem in more recent years. This is done. This is achieved by a number of different subjects. Clearly, universities, but also research centers that work in the space field. Located nearby Politecnico di Torino, like the Links Foundation, the Italian National Institute for Astrophysics, INRIM on metrology, and then we have a cluster, it's called Aerospace Cluster, that involves, again, institutions, but mostly companies, both large companies and SMEs, more than 115. So we have the industrial part, we have the research part, and then also more recently, two players for startups, those that you see there, two acceleration program, one by the European Space Agency, and I'm leading that program. I'll tell you something more in a minute. The other one, Takeoff, is a public-private accelerator based in Turin and supported by CDP, which is a national development bank. I was mentioning this is a business incubation program. We run this together. I3P is the business incubator of Politecnico di Torino. I'm the chairman of that company. Then we have Politecnico di Torino, the Links Foundation, the regional government, the Chamber of Commerce. So you see many players around these initiatives. It's a node for space startups in a broader network at European level, and we are also coordinating other centers in Italy. Around this acceleration program, clearly we have a large number of partners from the industrial side, the financial side, and also from the research side. Until now, we have created our first 33 startups, and we are already collecting some money from investors, about a bit more than 20 million investment, and more to come, hopefully, in the next years. These are the startups. Again, the key point is that we have more startups doing technology, so upstream solution rather than downstream companies. It's really something quite unique related to our environment. All of this is possible thanks to the space activities conducted at Politecnico di Torino. Clearly, now I do not have time to go through all the different activities, but you see we range from satellite technology, the pattern communication, Earth observation, so on and so forth, down to the space economy. I'm an economist, so I work in that field. And this translates also into a number of projects that involves space or aerospace. Before you have heard about MOST, another project that is led by Politecnico di Torino is called Space It Up, a large-scale project with many partners spread all over Italy. And in a minute, I'll tell you something about what you see here reported as NODES. Ideas, you have heard about this project. It's more on the infrastructure, laboratories, not only for the part on aviation, let's say, but also for the part related to space, with 2 laboratories, human and stellar. Talking about recent endeavor or nice success conducted by colleagues, I'm just mentioning this one because colleagues of Politecnico di Torino have been collaborating with NASA and the Italian Space Agency to develop a device that has been put on board of a rover that actually landed on the moon this year. This device, this payload, was a transmitter and receiver of GNSS signal, and it was a fundamental mission to prove the possibility of having also on the moon a system of communications analogous to the GPS we use every day, and this will be functional also to the development of the lunar economy in subsequent years. Okay, so now I'm using the remaining part of my speech on one specific project that I've been leading for the past 3 years. It's called NODES, which stands for Northwest, our region in Italy, Digital and Sustainable. It's a large-scale project. The value is about 120 million euros. All the activities have been divided into different spokes, thematic spokes. And in particular, I've been leading this one on aerospace and sustainable mobility. 60 million euros, 80 researchers, 7 organizations, and a lot of companies involved. What is peculiar about this project is that it is meant very much for technology transfer, impact in terms of creation of new companies, filing of new patents, high TRL type of project. And this is what we have been trying to do. The partners in the project are more local, because the idea is that we want to work to set up an ecosystem in the northwest of Italy. So we have the 2 universities and a business incubator, foundation, and research centers that are all located in the region, in the Piedmont region. And for space, clearly we have done a number of different research lines that they have been organized as components of a space mission with a focus on micro, nano satellites, Earth observation, and other space system. You see, our claim is not doing basic research here. We are not doing basic research. We are doing high TRL applied research with the objective of moving towards commercial exploitation. And for this reason, we have funded what we call academic proof of concept. So we went to our colleagues and say, if you already have a patent, a solution with high TRL, you can apply to us, and we will give you additional resources with the objective of translating your result towards the market. And we have created, as I'll show you in a minute, also some startups. On the other side, we have funded a number of SMEs to develop joint projects in space. Clearly, all these projects are very nice. No time to pick each of them, but just to have to give you an idea, these are example of what we call POC by researchers in space technologies. And then we have industrial projects. And again, you have different examples, those more focusing on data, exchange. Other are more related to specific technological component of space assets. So many of them. And we have been very much pleased because some of these projects have been awarded to former startup, supporting, that was our objective, their scale-up phase and the go-to-market process. Thanks to the project, we have also created new startups. One, and I have here a couple of examples. This one, Astro, is a company that is developing a tethered system for satellites. These are 2 satellites with a joint, very complex by a technological point of view, with the objective of taking images of the ground of Earth, allowing a better representation of the 3D in 3D. So rather than having flat images, these allow a better resolution of 3D imaging on the ground. Another one that has been created during the project is called MESPAC. In this case, this is a downstream company. The idea here is matching, and they're already doing this, data taken from satellite with data measured in situ on the seas, in the ocean, in order to have a qualification, a characterization of specific portion of the ocean in terms of wind, current, and the capability of generating electricity through an offshore wind plant in the area. Another one, we go back to the upstream sector. Diplotic, this company, that they also got the prize as the best startup in Italy in space last year. They are developing an inflatable arm, a robotic arm, to be used in space. Another solution. Beyond the startups, I would like to close my speech on the results of NODES with a couple of examples about applied research and impact. That's what we would, as a researcher, all of us really want to make an impact. So among the many outcomes, I'm just picking 2. The first one is about a new solution in the field of global navigation system. As you might know, now worldwide we are facing an important issue, a critical issue, which is the jamming or spoofing of GNS signal with very important impact for the safety in many areas, especially in the case of transportation. So this was the challenge, I mean, the problem. During the project, a group of colleagues has been working on this, and they developed what is now a prototype. Hopefully, soon this will be a product, maybe marketed by a startup. That what you see reported here is a system for the automatic and quick identification of the presence of an ongoing interference, illegal interference on the GPS or in general GNSS signal. It has a specific characteristic, as it is portable, so it can be used everywhere, and it has an automatic recognition of the type of interference going on. A completely different, but still impactful result has been the development of a digital twin with a very high resolution level for our city, for Turin, some picture that you see are represented, and we hope that this platform of data will allow subsequently many other impactful applications for improving the quality of life in the city. Finally, all the outcomes of this project will give rise to what we have called the Space Knowledge Gateway. This will be also a website. It's going to be launched in 2 weeks from now. We will pull together here all the resources labs, specific capabilities of research groups active in the space economy, allowing an easier interaction with companies. We will cover this different field in space, in our Space Knowledge Gateway. Thanks a lot for this opportunity. I'll be here and also eager to exchange ideas and give you more details about these projects. Thanks. Gianmario, are you coming here? Okay.
Thank you, Giuseppe. Thank you to all the colleagues for the insightful presentations. Years of work in a nutshell, in 1 hour of talks. So now, before we shut down the microphone and leave the floor to our networking aperitif, let me thank again all the guests that are here today, and I invite you to stay for a few words and for networking, for meeting the colleagues who spoke today, for meeting the director of our Japan Hub. And last but not least, let me praise and give credit to all the people from Polito that contributed to this big effort. This was a big investment of time and resources and of enthusiasm by people of the Japan Hub, people of our communication service, people of our internationalization services. Some of them are here to implement it, so let me just, I invite you to give a round of applause to all the people who contributed to build these 3 intense days of Politecnico di Torino at Expo Osaka. Thank you again. In 5 minutes we will have the catering and something to drink, and it will be